Okay, hello everyone. In this video, we are going to talk about how to quantify the Gibbs free energy. It turns out that there are a couple of methods, and this is going to be what I'm calling method 1. So there are two ways to find delta G. Method 1 is using the relationship that we defined earlier, where delta G of the system is equal to delta H of the system minus T delta S of the system. Okay, so in this example, we have potassium chlorate, a common oxidizing agent in fireworks and matches. That should be matches. It undergoes a solid state disproportionation reaction, which is just a fancy way of saying that it decomposes according to the reaction that's given here. And so if the enthalpy of the reaction is negative 144 kilojoules, and the entropy of the reaction is negative 36.8 kilojoules at 298 Kelvin, we want to calculate the we want to calculate the Gibbs free energy of the reaction. So we know that delta G of the reaction is equal to delta H of the reaction minus the temperature times the delta S of the reaction. So to do this, I'm going to plug in some values. Now, notice that I have my entropy in joules and my enthalpy in kilojoules. So I'm going to convert my enthalpy to joules. So a negative 144 kilojoules. In 1 kilojoule, there are 1,000 joules. And so this is equal to 1.44 times 10 to the 5th joules, negative. And so negative 1.44 times 10 to the positive 5 joules minus T, which is 298 Kelvin given to us in the problem, times negative 36.8 joules per Kelvin. And so if I calculate this, I get that delta G of the reaction should be equal to negative 1.33 times 10 to the 5th joules. And so this means that since our delta G is negative, this means that the reaction is spontaneous. And since the delta G is a large number, it means that this reaction is very spontaneous. Because remember, we talked about how the sign of the Gibbs free energy tells us whether or not the reaction is spontaneous, whereas the magnitude, the size of the number, tells us how spontaneous that reaction is. Okay, so stay tuned. In the next video, we are going to calculate the Gibbs free energy via the other method.